Okay, well, so now we're going to look at some of these graphs. This is the one we just made, but let me back up. And for now, anyway, we're not going to worry about the code, but you can see that this is their code. I'm using their code. I didn't write any of this. They call this the Wolfram model. We have x, y, x, z goes to x, z, x, w, y, w, z, w. This is what we were doing. Mm-hmm. And we're starting with our initial setup. 1, 2, 3, 4. Remember we drew that?
Yep.
And then the first iteration, is that what we saw?
Yeah.
Indeed.
Okay. And then the second iteration, unfortunately we put the computer on the whiteboard so we can't verify that we got this right, but that's how they drew it.
It looks similar to what we have.
Yeah, and I think we got it right. Did 5 have 3 coming in and 2 going out? Yeah, actually I can see it behind the computer on your circle diagram. Okay, yeah. So that's that. And then, so now can you identify a couple of places where we would now have to look where 2 things were going out?
We have 3, we have 4, 5,
and 2.
Yeah, so it's going to get complicated. And I'll tell you one thing I don't know the answer to. 4 has 3 bits going out.
So do you do it like 3 times for like this one, and these 2?
Yeah, I don't know. But maybe we can see what we can find 4 on the third step.
Huh.
So 4 still has 3 going out.
Yeah, so here's whatever the rule is, and I don't know this all well enough to know what the rule is, but that's what it looks like at the third step.
It's pretty cool.
And down below here, I've actually, again, used their code to look at the first 15 steps. So we don't have to go through this. So tell me, just describe some of the things. This is the first, like, let's see. So that was 0, 1, 2, 3. That's the one we just saw above. 4, 5, 6, 7, 8, 9.
Wow.
What do you see going on here?
The points seem to multiply pretty fast. You seem to be adding new points at a very fast rate.
Okay, yeah, so that would be a very interesting question to ask, is how many vertices do we have?
It also doesn't seem like it's holding a steady shape. Like, it's not making a specific shape. It's just kind of like wildly going around.
Yeah, they are certainly making some choices about how the things get oriented, because if I bring it down here, you can see some... Ooh, can I get all 9 of these on the screen, up to 15?
Yeah, these sort of look similar. They've got like these big...
So sometimes it's
you can see where like the 1 to 2 is.
It's like the same shape. It's just these 2 look very similar. This one's just flipped upside down.
Yeah, so sometimes it appears to be making a choice to present it facing up or facing down, but if we could adjust for that, it does kind of look like the shapes eventually start staying relatively consistent.
Yeah.
And that was just what we got starting from this relatively simple starting point with this very simple rule that we have. But as you could imagine, we could have very different rules. So do you want to modify this rule a little bit, and we'll see what it looks like? Actually, going out to 15 takes a long time, so we'll only do 9. But you could modify this rule.
19.
19 will take longer than 15, so let's just do 9. Then we'll get 9 on the screen. So how would you like to make just a simple modification to this rule?
Well, let's add 2 new points instead. So we can do maybe... We can add a new point, V, in place of...
I'll type it. You tell me.
Instead of XW, we can put XV.
XV. Okay.
So add in 2 new points every time.
All right. This could be interesting. In fact, let's do this only for the first 3, just to see what does it look like. Okay. So that worked. So that's interesting.
It's very
And
linear.
now let's do 9 of them.
Interesting. So it's a very, very different structure.
All right. So tell me what you think here.
Well, this it stays out in these constant chains. So before, I think you're a lot more likely to get these groups of multiple connections coming out of one point. This one, not so much. Actually, you see these chains. There's one point here that has, this one only has 2. This one has 2 going in. So you don't see a lot that have 2 going out of them. It's one of the only ones in the shape.
Yeah, it's very interesting. Do you want to make? Oh, sorry. Go ahead.
Yeah, I also thought that there were 2 or more than one starting point. Like if you look at this one, this point, and this point, you can start at either of these points, but you can't get to this point from that point.
Huh. Okay. Yeah. Neat. You're right. All right. Do you want to make up a rule and see what it looks like?
Yeah.
Okay. So going back to the original rule, just this was a W, right? And that's what we had seen originally. Yep. Okay. So
Okay.
good. I know this works.
So let's flip all of them. So instead of X, Z, we do ZX.
Oh, neat idea. Z, X.
And
Okay.
then WX.
WX, WY, and WZ. Okay. And we'll see what this looks like here. What do you think how it's going to change?
I mean, I think it should be a similar
Should be similar.
web structure. Yeah, it definitely is different.
You're just almost reversing the connections in between.
Still, it's producing a different shape though. But
Yeah.
it is kind of this big web. Still,
All right, yeah, that's interesting. So reversing didn't simply keep the same shape and reverse the arrows. It actually made a
different shape.
completely different shape. Cool. All right, so we're going to look at one last thing now.
Okay.